Assalamualaikum and a very good day everyone. So as for today, we are going to learn on how to design a pre-stressed concrete structure. So as what we have already know, that for a pre-stressed concrete structure, we are going to design for serviceability, right? So as for this week, we are going to cover on the minimum section as well as the pre-stressed force calculation. So these are the lesson outcomes that we will be covering for this week's lecture, which the first one is that at the end of this lecture, you should be able to understand the stresses involved in the pre-stressed concrete design. Then the second one is to propose the size of the pre-stressed concrete section based on the minimum section moduli. And the third one is to determine the minimum required pre-stress force for the specified eccentricity. So these are the three lesson outcomes that we are going to cover. So we will begin on the introduction to the design of a pre-stressed concrete member, right? So it will be designed based on maintaining concrete stresses within the specified limits at all stages during the service life, right? So we know that for a pre-stressed concrete member, we are going to consider the two types of conditions. One is during transfer, as well as during service, right? So we are going to have to bear this in mind, whereas we are going to have to maintain the concrete stresses within the limits, right? So we are going to discuss on the limits later, right? So you can see here for the primary design, it will be based on SLS, or the serviceability limit state, and this SLS, will be considering the concrete stress limits, the acceptable degree of flexural cracking. Then we are going to prevent excessive creep and also to ensure excessive compression do not result in longitudinal and micro cracking, right? So as what we have discussed previously, when we talk about a pre-stressed concrete structure, we know that it is bounded under compression, whereas basically this cracking can be avoided, right? So we are going to look into the limits of the crack limits that will be considered for the design of a pre-stressed concrete member. So this is the first limit that we are going to go through, which is the limits in the compressive stress. So these values are actually based on the Eurocode 2, which we have used previously for RC design, right? So we can see that we have these two important values, which are 0.6 FCK, which is for under action of characteristic loads, and also 0.45 FCK under the action of quasi-permanent loads, right? So usually as for this quasi-permanent loads, we are going to consider this as the service load, right? So we can see here, in the box, is the equation for the quasi-permanent load, whereas we are going to add up the GK, which is the permanent load, then plus with the pre-stressing force or the pre-stressing load, and plus this with a proportion of characteristic variable load, right? So we can see here we have this phi sign, which is actually the factor, that can be obtained from BS EN 1990 or Eurocode not, right? So we can see here that this value of this phi value or the factors for building is actually based on the categories, right? So this is the category for our structure, whereas we have category A for domestic and residential areas up to category H, which are for roofs, right? So we are going to refer to phi 2, whereas you can see for category A the value is 0.3. So if we are designing for a bridge, for example, or if we are designing for a parking structure, so we can see that the value of the factor becomes 0.6, and as for roofs, the value is equal to 0, right? So these are actually what is given here, is actually the factor, that we are going to multiply with the QK value, which is the variable load. So next we move on to the limits in the tensile stresses. So this limit is also stated in the Eurocode 2, whereas you can see that the limit of tensile stress in concrete will be based on FCTM, right? So this FCTM value will be based on table 3.1, which we have already used previously in the design of RC, and we can see here okay, that if the value, okay, of our stress in the concrete for pre-stressed concrete is less than FCTM, okay, which is based on table 3.1. Okay, so you can see here, okay, this is the FCK value, okay, which is our concrete class, right? So for example, if we are referring to class 40, right, so the FCTM value here is 3.5, right? So this is table 3.1, that is from the Eurocode 2, right? So we are going to compare, okay, the tensile stress that we obtain from our section, okay, whereas we are considering the pre-stress force as well as for the stresses that is due to bending, right? So we are going to add those up, okay, and we are going to compare with FCTM. Right, so this FCTM, if the value of our stresses is less or equal to FCTM, okay, therefore the section will be designed as an uncracked section. Okay, whereas we are going to consider the gross concrete section, okay, to resist bending, right? And then as if we have our tensile stress in the concrete is larger than FCTM, therefore the section will be designed as a cracked section, right? So we will discuss on this further later, right? So as for the permitted cracking, okay, in a pre-stressed concrete member, okay, it depends on the type, the method of construction, okay, that we are going to use, okay, for our pre-stressed concrete member, okay, whether it is pre-tension or it is post-tension, a post-tension structure, right? And we will also consider, okay, the conditions of exposure as well as the nature of loading, right? So we are going to consider all this, okay, in order to determine the permitted cracking in a member. So this is table 3.1 just now, okay, and this is for the crack limits, right? So there are certain specified requirements, okay, that we have to follow, okay, when we talk about pre-stressed concrete member. So if we have, we are designing for a pre-stressed member with bonded tendons, okay, therefore the crack width is limited to 0.2 mm, okay, which is under frequent loading condition, combination, sorry, right? So this is for bonded tendons, right? So if you still remember, okay, we have already discussed, okay, on the two types of tendons, okay, that we can provide in a pre-stressed concrete structure, okay, whereas we have bonded tendons and also unbonded tendons, okay. So this actually depends on the method of construction, okay, as well as whether we are providing grout or not for our tendons. Then the next one, okay, is in aggressive exposure conditions, right? So these are actually the exposure condition of our structure, okay, whether which is usually depending on the location of our structure, right? So here, okay, we are going to consider the possibility of decompression under quasi-permanent load may be considered, right? So we have to consider of this as well, right? So this possibility of decompression is actually in relation, okay, to the compressive force that is induced by the pre-stressing tendon, right? So therefore we need to consider this as well. Okay, so then next one is for precast segments, okay, which will have the mortar joints. Okay, so for this type of segments, okay, or for this type of structure, cracks are not permitted, right? Okay, because we have this mortar joint which is very weak, right? So therefore it is designed to be in compression under all load conditions, right? So here, okay, we are going to consider that our structure, okay, is mainly under compression, okay, of the pre-stressing tendons. Okay, so the next one, okay, is the minimum amount of bonded reinforcement. So this is provided to control cracking, right? So we are going to provide this, okay, and the value will be calculated as the minimum requirement for reinforced concrete, okay, with A as minimum value, right? So if you still remember in the RC design, okay, we have already calculated on this value, okay, which is 0.13%, right? So we are going to use the same thing, okay, or the same value, okay, for our pre-stressed concrete design, right? So this will be the minimum requirement, okay, the minimum requirement of reinforcement to control cracking, right? So then we move on to the conditions of our pre-stressed concrete structure at transfer stage, right? So we are going to have two types of conditions. Okay, one is the transfer stage, okay, and another one is the service stage. Right, so for the transfer stage, okay, we know that, okay, when we talk about a pre-stressed concrete structure, we are going to have the compressive stress induced to our concrete. Right, so this is where, okay, we consider this as the transfer stage. Right, so at this stage, okay, the pre-stress force is higher, okay, than the value in long term. Right, so this is due to the stresses, okay, or the forces, okay, that is only subjected to immediate losses. Right, so at this point, okay, we do not have the losses in long term yet. Right, so we do not have the creep losses, okay, and also we do not have the long term shrinkage losses, right, and also the relaxation of steel. Right, so this is only subjected to the immediate losses. So later we are going to learn, okay, on the calculation of these losses as well. Okay, then it represents the transitory stage in the member's life, okay, whereas we are going to transfer the pre-stress force to our structure, okay, and the limits should be considered in both compressive and also tensile stresses. Right, so we know that when we have our structure that is subjected to this pre-stressing force, okay, usually the top part will be subjected to tensile, okay, and the bottom part will be subjected to compression. Right, so we know that we are going to have to consider these two limits. So at this point, okay, at the transfer stage, okay, this concrete is relatively immature, okay, whereas we know that it is not at full strength, okay, and it is at a critical stage. Right, so the concrete is not at full strength, okay, and it is relatively immature, so there is a possibility for the concrete to fail. Right, so therefore we need to bear in mind, okay, and we need to have to take careful measurements, okay, during this transfer stage. Right, so here, okay, I have listed the compressive stress limits, okay, which is particularly for the compressive stress as well as for the tensile stress. Right, so for the compressive stress limit, okay, which is already given, which is given by the Eurocode 2. Right, so we know that for compressive stress limit, it is limited to 0.6 FCKT. Right, so what is FCKT? It is the strength of concrete at transfer. Right, so usually for this part, okay, we are going to consider that the strength of concrete has achieved approximately 60% of the concrete strength. And then next one is for the tensile stress limit. Right, so as for this value, okay, the Eurocode has limited the value to be 1 Newton per millimeter squared, okay, which is for sections designed not to be in tension in service. Right, so we assume, okay, that our section is only subjected to compression. Right, so therefore we are going to consider the value to be 1 Newton per millimeter square. So that is for the tensile stress limit. So you can see here, okay, that the Eurocode has given us the compressive stress limit, okay, for both compressive and also tensile stress. So this is the clause, okay, that is given in the BSEN, okay, or the Eurocode 2. Right, so these are the limitation of the concrete stresses. Right, so you can see here local concrete crushing and splitting at the end of the pre and post tension members shall be avoided. Then local concrete crushing or splitting behind post tensioning anchors should be avoided. Okay, and also the strength of concrete at application or transfer of pre-stress should not be less than the minimum value defined in the relevant European technical approval. Right, so we can see here the concrete compressive stress, okay, limit, okay, is given here, okay, which is 0.6 FCKT. Right, so and this FCKT is the characteristic compressive strength of the concrete at time t, okay, when it is subjected to the pre-stressing force. Right, so this is the value that as what I have mentioned to you just now, okay, is that usually we are going to consider that this value is 60%, okay, of the design concrete strength. Okay, so for pre-tension elements, okay, the stress at the time of transfer of pre-stress may be increased to K6 FCKT if it can be justified by tests or experience that longitudinal cracking is prevented. Right, so this value, of 0.6 FCKT, K can also be increased up to 0.7. Okay, however, it has to be justified by test, right? So that is for the clause. Okay, that is from the Eurocode 2. Right, so these are the basic expressions in the pre-stressed concrete design. Right, so these are the expressions, okay, that we have already seen previously in our previous lecture. Right, so which I have already shown you, okay, on the stress block. So we have the stress block and we have already derived these equations. Okay, whereas we can see this first portion of the equation is due to the pre-stressing force. Then as for the second portion of the equation, it's basically based on the bending stress, K, of our beam. Then the third equation, the third expression, K, is due to the eccentricity of the uh, tendon, right? So which is also known as the location of the tendon, right? So you can see here that we have these four equations, K, which is mainly due to the moment maximum and also moment minimum. So just to recap back, right, so when we talk about moment minimum, okay, it means that we are referring only to the self weight of the structure, and when we are referring to the moment maximum, usually we are already considering the maximum moment that considers the self weight, okay, as well as for the variable action in our structure. So it is of more of the total of the loadings, okay, that we have already used to calculate the value of moment. Right, so these are the equations, okay, that is based on the stress distribution of the section. Right, so based on this equation, right, so these are the equation that can be derived on based on the stress block. Right, so this is the thing that I'm talking about just now. Okay, but as you can see here, okay, that we have these equations, okay, and I've also explained to you, okay, with regards to the stress distribution, and also we have already did an online exercise, right, which we have already discussed previously, right? So if you need, then you need to recap back, okay, on what we have learned previously here, right? Okay, so next we move on to the pre-stress design requirements, right? So we are going to go more on the calculation, okay, on this pre-stress design, right? So these pre-stress design requirements will be based on stress distribution across the concrete section, okay, as what we have discussed previously, okay, and it is to be used together with permissible stress appropriate to the strength of member. Right, so these are the conditions, okay, whereas we can see that we are going to have the initial transfer, okay, so initial transfer of pre-stress force with the associated loading is usually just the beam self weight, right? So this is the initial transfer stage, right? Okay, whereas we have the transfer, okay, of the pre-stress force, right? So usually at this point, okay, we are going to consider only the beam's self weight, right, as the external loading. Then at service, okay, after the pre-stress losses, okay, we are going to consider the minimum and also maximum characteristic loading, right? So usually if we are going for only a single span, so therefore we are going to consider only a maximum characteristic loading. However, if we are dealing with a continuous beam, for example, so therefore we are going to have this minimum and also maximum characteristic loadings, which is usually placed as alternate loadings, right? So then the third one is at service with quasi-permanent loading, okay, with only a proportion of characteristic variable load, right? So previously we have already discussed on this, okay, as we have this quasi-permanent loading, so we have already combined, okay, the value of GK, K, as well as for the value of QK in consideration of the factor of safety, right? So load for the loadings, so all loads that will be encountered by the member throughout its design life has to be considered, and also as for the minimum values, right? So this is actually governed by the construction techniques used, right? So in view of the pre-stressed concrete design, okay, we are going to have two types of methods. Okay, one is for the tension method, and another one is for the post tension method. So there is a bit different, okay, between these two types of construction method. Okay, so in view of the design requirements, okay, for beams with cantilever span or continuous beam, right, so we are going to have to consider loading patterns, okay, of the live loads at surface, and also to determine the minimum and maximum moments, right. So this is where, okay, which I have mentioned to you just now, okay, whereas we have this alternate loadings, right. Then for a single span, okay, which is usually for a simply supported beam, right, so we are going to consider minimum moment at transfer, okay, whereas we are going to consider only the self weight of the structure, okay, and also maximum moment at service. So we are going to consider a higher value of moment at the service stage, right. Okay, so in the design of a pressurized concrete structure, so these are the stress limits that we are going to consider. So what I have mentioned to you just now, okay, is just on the limits at transfer. Okay, so we have F prime max, okay, which is equals to 0.6 FCKT, and also we have F prime minimum, okay, which is the tensile stress limit, okay, which is equal to -1 Newton per millimeter square. So if you can see here, okay, we have this negative sign, okay, since we are referring to the tensile stress. So when we talk about tensile stress, okay, in a pressurized concrete structure, the sign convention will be negative, right. So we are going to take the compressive stress as taking the positive sign, right. Then at surface, okay, we are going to have a different compressive stress limit, okay, whereas we are going to consider F maximum equals to 0.6 FCK. So just now at transfer, we are considering FCKT, which is the strength of concrete at transfer, but at surface, we are going to consider only the FCK value. So as for the tensile stress limit, right, so we have F minimum. So as for this at surface, we are going to consider that we do not have any tensile stress, right. So if we can still remember, okay, when we have a pre-stressed concrete structure that is subjected to a pre-stress force, okay, when it is under service, under loading, okay, we can see that our beam straighten. So at this point, okay, we consider that we do not have any tensile stresses acting at the bottom of our beam, right. So that is why the value here is equal to 0. Okay, so this is the figure, okay, whereas we can see this is the beam at transfer, okay, whereas we have this P naught, okay, or the initial pre-stress force at transfer. So it is in use to our structure, and you can see here this is the loading, okay, that is subjected to our beam. And as for the transfer stage, okay, we can see that we have this loading that is acting downwards, okay, and it is only considering the self weight of the beam, right. So in view of the stress block, okay, so we can see here at this point, so this F prime T, okay, is for the stress that is acting on our structure, okay, and this F prime minimum, okay, is the tensile stress limit, right. Okay, and as for F prime B, right, so this is the value for the bottom part, okay, of our structure, okay, and this value should not be more than F prime maximum, right. So this F prime maximum is for the compressive stress, right. So next one is for the service stage, right, whereas we can see that we also have this K P naught, right. So what is this K? This K is actually considering the factor, okay, that is due to the pre-stress force, right. So here, okay, when we talk about service stage, okay, we already have to consider, okay, the value of the pre-stressing loss, right. So that is why we have to multiply the value by this, right. So instead of just taking P naught, right, so now we have to multiply the value and reduce the value a bit, okay, due to the pre-stressing force, right. So and we can see here, as for the loads, okay, the loads here is considering W max, okay, or W maximum, whereas we are going to consider the self weight of the structure itself plus with the external load, right. So in view of the stress block, Okay, so you can see here that we have Ft, okay, which is F for the top part of our beam, okay, which will be compared with the limit of the compressive stress, okay, which is F maximum, right? So at this point, the value should not be more than F maximum. And as for the bottom part of our beam, right, so we have here FB, okay, which is the stress at the bottom fiber, right? So this value must be larger or equal to F minimum, right? So this is for the tensile part of our structure, right? So we can see here F prime minimum, F prime maximum, F prime minimum and F maximum are the appropriate permissible stresses at transfer and at service, right? So these are the limits. Okay, and we have P naught as the pre-stress force at transfer, and also K is the loss factor, right? Which corresponds to the pre-stress loss, right? So we can see here from the stress block, okay, so we can see that we have the tensile stress, okay, which is acting on top when it is at transfer, okay, and also it is acting at the bottom, okay, when it is on the surface, okay, and also we have the compressive stress limits, okay, which is for the bottom and also top part of our structure, right? So this is an overview, okay, of what we are considering just now, okay, in view of the limits.